Hello dear students, today we are going to discuss very important concept for all the competitive exam. From this, minimum one or two questions will come in all the exams. The name of the concept is aromaticity. Even from recent JEE means exam, there are one or two questions from this concept. So benzene and benzenide heterocyclic organic compounds mainly classified into these types: aromatic, anti-aromatic, non-aromatic. Aromatic is not only related to smell. Aromatic compounds are nothing but the compounds which are in these conditions. Like the compound should be cyclic, planarity, conjugation, and that also should obey Huckel's rule, which is nothing but 4n plus 2 pi electron rule. See, we will discuss what exactly it is. Cyclic means, let us take benzene ring. So, the given compound should be in cyclic form or ring form. And that should also have planarity. And it should also contain conjugation. Just conjugation is nothing but if the double bonds are located at alternate positions, if the p orbitals are aligning in the same direction, then the pi electrons will move from one place to another place, and those pi electrons will move throughout the ring. That phenomena we will call it as delocalization process. So that is nothing but conjugation. In simple way, the movement of pi bonds from one place to another place is called conjugation. That we can able to see only in case of conjugated double bonds, which means the double bond should be at alternate positions, like double bond, single bond, double bond, single bond, like that. And very important condition for this is Huckel's rule. What exactly Huckel's rule means? Just we are taking the formula for Huckel's rule, that is 4n plus 2 pi electron rule, which means here n is nothing but integer. It is not related to number of rings or number of carbons. It is purely integer. Either it may be 0 or 1 or 2 or 3. Suppose if you substitute 1 in the place of n, or if you substitute 0 in the place of n, then what you will get as a electron number? Yes, you will get 2. 2 electrons. Suppose if you substitute 1, you get 4 electrons. Oh, sorry, 4 not 6 electrons. And suppose if you substitute 2, you get 10 electrons. Which means in the given compound, if any of these number of pi electrons are located, then the given compound considered as Huckel's rule compound or aromatic compound. Just we will discuss for benzene. So benzene is in the form of cyclic, and it is also in the form of planar, and it is also obeying conjugation. So that is nothing but delocalization of pi electron throughout the ring, and which also obeying Huckel's rule. Why? Because if I substitute n value is 1, so we get 6 electrons. So in benzene, how many pi bonds are there? 3 pi bonds. For every pi bond, there will be 2 electrons. So 3 into 2, 6 electrons. Hope it is clear. Now coming to the second compound. Before going to second compound, just we will talk about other type of aromaticity. So anti-aromatic compound. Even this also, the compound should be in cyclic and planar, and it is also should contain conjugation, and it should have 4 and pi electrons. So here also n value you can substitute 0 or 1 or 2 or 3, anything it may be. So if you substitute 0 here, how many electrons you will get? Yes, you will get 0 electrons. Yes, so the rule is what, students? 4 and pi electron rule. So if you substitute 0 value in the place of n, what you will get? Yes, 4 into 0, which will be 0 electrons. And suppose if you substitute 1, 4 electrons. If you substitute 2, yes, 8 electrons. So this is how we can able to substitute n value in the 4n pi electron rule. So that is about anti-aromatic compound. See, coming to the next one, non-aromatic compound. Just the compounds which doesn't obey any of above conditions, those all comes under non-aromatic compounds. Yes, so these are the explanation of aromatic, anti-aromatic and non-aromatic. Now directly we'll go for examples, because the understanding concept is one thing and solving questions is different thing. So just where to apply, how to simplify the question, all we are going to discuss in the examples. Yes, coming to the second example, which is this. Here, just by seeing itself, we can able to understand the compound doesn't have conjugation. To exhibit conjugation, the double bond should be at alternate positions. But here, those double bonds are not at alternate positions. If there is no conjugation, that comes under which type of compound? Yes, it comes under non-aromatic compound. So that is the non-aromatic compound. Even though it has 4 pi electrons, those are not in the conjugation. That's the reason it's not comes under anti-aromatic, it comes under non-aromatic. Yes, coming to the second case. Yes, if you see this molecule, just here also 4 pi electrons are present. These 4 pi electrons can make conjugation not throughout the ring. That's the reason even this also comes under non-aromatic in nature. See, conjugation in the sense the pi electron should revolve or should delocalize throughout the ring. Then only we can able to say that compound is in the conjugation. Coming to the fourth example, it's like cyclobute 1,3 diene. So in this molecule, just how many pi electrons are there? Yes, 4 pi electrons are present. Yes, 4 pi electrons are present. Those are in conjugation like this. So the conjugation is happening throughout the ring and it contains 4 electrons and it is also having planarity and cyclic in nature. That's the reason it is not having 4n plus 2 pi electron rule. It comes under 4n pi electron rule. See, 4 electron where we observed 4n pi electron rule only. That's the reason this molecule comes under which one? Yes, it is comes under anti-aromaticity or anti-aromatic in nature. Hope it is clear. So the first one is aromatic, second, third one are non-aromatic, fourth one is anti-aromatic. Is coming to the second example. See, it's not only related to benzenide compounds, it is also related to heterocyclic compounds. Even there also benzenide, non-benzenide will be. So heterocyclic compounds. Just you can see this example. Here nitrogen is act as a heteroatom. Heteroatom means the high electronegative atom should be located between the carbons in ring. Just if you observe this, the conjugation is taking place without involvement of nitrogen lone pair. Yes, you can see the resonance. So there will be no involvement of nitrogen lone pair in the conjugation. Without involving itself, the complete conjugation is there and it is in the form of ring, it is in the form of cyclic, and it is also in the form of 4n plus 2 pi rule. So how many pi electron students? 1, 2, 3, 3 2s are 6 electrons are present in it. So that's the reason pyridine is having which one? Aromaticity. Pyridine is having aromatic in nature. And coming to pyrrole case, just you have to observe carefully. The total pi bonds in the molecule is only 4 Two pi bonds are there and pi electrons are 4 like this. So these 4 cannot make complete conjugation in the molecule. That's the reason to make complete conjugation, the nitrogen lone pair also involved. So just you can see little big I am writing. So this is the structure of ferrol. Hope everybody can understand this. See here, this lone pair of electrons will shift here. This lone pair, this pi bond is moving here and this is moving here. So what is happening here? Nitrogen lone pair also involving to make complete conjugation in ferrol. That is point number 1 in this. Now you can able to count total number of pi electrons, how many involved in the conjugation. Just 2 pi bonds, which means 4 electrons, and 2 electrons is also involved from nitrogen. So that's the reason total how many electrons? 6 electrons. So 6 electron rule where we observed? Yes, we observed under 4n plus 2 pi rule or Huckel's rule. That's the reason even ferrol is aromatic in nature. Hope these two examples are clear. See, one more very important point which we have to understand here. See, this lone pair of electrons not involved in conjugation, but in ferrol, nitrogen lone pair is involving in conjugation. That's the reason this is considered as good base comparatively ferrol. So this is acting as a good base because base is nothing but what? The lone pair of electrons ready to donate outside species. That's the reason this is also called a Lewis base. Lewis base. Hope it is clear.